Okay, welcome back to another video. Today, we will talk about asynchronous programming and why do we need it. Um, Actually, we may face such a problem that our program is very slow. It has to perform a lot of different simple tasks, but anyway, it takes just too much time to wait. And we can optimize it, we can make it very efficient, and still it will take a lot of time. And you might think, well, we should use a better computer. Actually, not necessarily. The matter is that we are using only one process and one thread, and we use synchronous programming to do that when each task is performed one by one. Now, there are ways to solve such problems. So, today we will talk about multiprocessing, multithreading, and asynchronous functions. First of all, let's have a look at how our synchronous code would do something. Let's imagine that we have some function. Yeah, I'll call it like this. That is going to just print different numbers. But but we would emulate that it is very busy, you know, very busy. Um, to do that, we would use function sleep from the module time. So go time dot sleep and let it be 1 second. And we should call this function as well. Let's look at that. And we have to wait for each iteration. And as you see, it takes pretty much time because we wait. But usually, when you have such time-consuming tasks, there can be two options. First option is that this task requires a lot of different resources from your computer. That's why it's time-consuming. The next one The next option is that we should wait when we ask something else to respond. For example, we make the request to the database or to some server, or we're trying to download something. Anyway, in all these cases, we are communicating with other hosts, with other computers, and your computer is not really that busy in such moments. So, um, there are ways to deal with both of the ways. First of all, I'll show you something. You can call your task manager, and as you can see, there is only one Python interpreter right now. Why? Because this Python interpreter is from the Visual Studio Code. We can even close it. Uh, Globally, there is no Python interpreter that is active right now in the system. It's just the one inside of Visual Studio Code. Now let's run our program and look what happens. As you can see, we have a new processor here that's called Python, and it is only one of them. And we're done. Now, if we are dealing with some tasks that is very resource consuming, we can ask our computer to dedicate more processes for our for our program. Yeah, so we can, for example, start rendering the video, and at the same time we can ask our program to perform some other not very demanding functions, and the rendering will be somewhere in the background. To be exact, in the dedicated process. Let's try that. For that, we need to input multiprocessing module, and from there we input process. We need only this for such a simple example. And input and time is still here. So we have a function, just a function. It's pretty simple, where we print something and sleep after each iteration. Now we need a construction that is called the main fork. If name is equal to main. This construction is pretty common, and there is a recommendation to use it always, but when you are dealing with multiprocessing or multithreading, it is a must. In this, what do? We make up a cycle where we create new processes. So our variable is a process, and we send one parameter. Target is equal to the functions that we want this process to perform. And then we start this process. And we are doing it again and again and again and again and again. So it will be 5 processes, right? Let's see what we have. Without this, what would we have? It would take us 5 times per 20 seconds. And as you see, these processes are going simultaneously. Why? Because we have 6 Python processes here, 1 for the main interpreter for our program, and 5 are dedicated processes that we're creating right here. Now, this is a pretty good way to work with some resource-consuming tasks, but it definitely takes a lot of resources from your computer. So if you are working with some, I don't know, requests to the database or requests to the service, it is not the best way to address such an issue, because you will just take all the resources of your computer for doing nothing, literally. It's just too much, right? For that, we can use 2 other ways. First one is multi-threading. Now, one can say that Python doesn't have any real multi-threading, and this person would be right. But we can still emulate it. I need this function for this example as well. Yeah, so for this we should input threading, or from threading input thread, if you can, if you would like to address it directly. And we have the same fork, and we produce different threads. So how is it going? One process can have a lot of threads, okay? And we can still do it, and they will do it kind of simultaneously, but not exactly, right? So let's try that. As you can see, we're still over here because Python, and over here we have only one Python process, right? We remember those are threads, not processes. So why does it happen? It happened because our interpreter understands that when this is going on, we are doing particularly nothing, right? So we don't need to stop here, and our resources of the process can be freed to start performing another thread. Sorry. It is kind of a good way, but it really depends. Because Python doesn't have real multiprocessing. Moreover, if you're multi-threading, sorry. Moreover, if your thread, the address, one and the same variable, they are competing for the resources, and you really can't control which thread is going to be first. So it may like get some chaos into your programs. That is okay. So to avoid that, we would better use not threading, but something else, which is called asynchronous programming, which we will use a lot. We will use it really, particularly in every project, because we are going to do something connected with networking. Let me check, everything is fine. How does it work? Basically, it is a very like cool mind game with jungling, uh, juggling, yeah, juggling the generators. So for it to work, we need to input a CNC model. We can do it without a CNC, but it would take a while, and it is pretty complicated. And we need a lot of generators, so it's quite difficult. So each functions that we are going to perform in asynchronous way, we need to define with the word async before def. And as you can see, we have functions that takes one argument that's going to be a number, it prints this number, then it sleeps for this amount of seconds, and then prints this coroutine is done. Why coroutine? Because all the tasks that you put into the queue are called coroutines. So basically what happens here, when we call our first coroutine, we start performing that, and when we say, oh, you know what, I need to wait here, each asynchronous method needs to be awaited. We're gonna wait here, but you can go further. You can go to another coroutine. And when we are done with this, we can continue performing our coroutine, this particular one. But that's not that simple. Like, of course, okay, you have asynchronous function very well, but how are you gonna call it? You can't just call it from nothing. First of all, you need to group them. You need to group your coroutines using asynchronous manager, a context manager async with. You call async.task group, and for each you use this command task group dot create task, and we send target as well. We send the function we are going to put as a task into the queue. Task group basically is the queue of tasks that you need to do. You can write it in different ways. You can do it manually, not in a list, of course, and not in a cycle. You can make them like task is equal to task group dot create task, gives the function task2 is equal to task group dot create task second function, and so on. But just to make it short and simple, I did it like this. Anyway, it's not like a manual, it's kind of my oh my god, research journal. So, and to call all this thing, we just call async.run and our group function. Make sure to call it You're not just sending it there, you are calling it in there. In this case, what will we have? Let's think. So, we are making 15 tasks and we are starting to do all of them. So it's going to be 1, 2, 3, 4, 5, and further and further and further. But each of them will stop in here, and only then they're going to write the next. Look at here. It's going to sleep 16 minus I. So the more is I, the less is time remaining to sleep. Actually, it means that they will like end up in a reversed way, because, for example, coroutine number 15 will go 15 and it will sleep 16 minus 15 just 1 second, right? Coroutine number 1, for example, will print 1 and sleep for 16 minus 1 15 second. Of course, coroutine 15 is gonna end faster. Let's try that. We have all our numbers, and as you can see here, voila, we have everything done correctly. So as you can see, despite our first coroutine hadn't ended, our next coroutine already started. Okay, so that's how asynchronous programming works. Today we talked about multiprocessing, multithreading, asynchronous programming. How does it work? When do we use them? I guess it was a pretty useful video. If you are still here and if you are still watching me for some reason, thank you very much. I'm very open to all the advice you can give me. It would be pretty helpful. So see you in the next video. Bye.